Hello everyone and welcome to Mathssteps. Today we are going to learn how to solve simultaneous equations. Here I have prepared a set of steps for you to follow, and I'm going to explain each of these steps one by one while we solve equations, right? Simultaneous equations. Okay, let's have a look at the first one. Now, one thing that I want to explain to you before we begin solving the equations, simultaneous equations, is I know when you decide on which variable to cancel out or to get rid of, for example, the signs might be minus or might be different, or might be both minus or both the same, both plus, okay? And then you have to think whether to choose subtraction or to choose addition. And in my opinion, I mean, you can do whatever you want, but that can get sometimes a little bit confusing, especially if you are in a test position. It might be a little bit confusing, all right? So what I'm going to teach you today is you just think of this. You are going to only use subtraction to get rid of the one of the variables, okay, to cancel one of the variables out, and to be able to cancel that variable out, whether x or y, okay, then to cancel that out, both of them should be a positive. So change both of them to a positive sign. I'm going to teach you how. And of course, both of them should have the same number of x's, if they're x's, or the same number of y's. For example, 2i take away 2i, 0. Okay, 3x take away 3x, 0. So make sure you choose, so you stick to one variable. You change the sign if they are both different. You change both of them to positive by multiplying one of them. If one of them is negative, for example, multiply the whole equation by -1. And be careful, you need to change the coefficient. Well, you need to change both of them to the same number of x's or same number of y's. So let's get down to work now, right? So this is pretty straightforward. You can tell straight over, I'm going to choose the y's. Okay, this is a variable I'm choosing. Why am I choosing this one? Same number of y's, 2i, 2i, and both of them are positive. So straight away, I'm going to subtraction. Remember, just subtraction, right? For all types of simultaneous equation, stick to that. So let's take them away. So this one is going to, I'm going to draw a line here actually straight away. 6x, take away 4x, make 2x. Okay, 2y, take away 2y. I can cancel them out just like that straight away if you want. And 15, take away 11 equals 4. And so divide by 2 both sides, because you need to get rid of the 2, divided by 2, divided by 2, and the answer is going to be x equals 2, just like that. Now, the solution doesn't stop here, because we need to find the value of y. Now, which of the equation you can use either? You can use the first one or the second one. I'd advise you to choose the one that has smaller numbers of coefficients. So this one has smaller 4, 2, and 11, just to avoid maybe complication with working with large numbers. Okay, the smaller numbers, the easier the work for you. So I'm going to choose the second one. So it is going to be this one, 4x plus 2y equals 11, all right? And then instead of the x, I'm going to put 2. So 4 times 2 equals, no, plus 2y, I'm very sorry, so plus 2y equals 11. So 8 plus 2y equals 11. Now get rid of the 8 by doing -8 minus 8. 2y equals 3, right? So y, 3 divided by 2, so divide by 2 both sides. And then so y is going to be 1.5. There you go. So let's have a look. Have we subtracted? Correct, we did. Instead of x, so 8, yeah, absolutely correct. So x equals 2, and y equals 1.5, right? The solution of my first pair of simultaneous equation. Let's have a look at the equation number 2. Right, again, lucky this time as well, because I can see even both x's and the y's are both positive. I'm going to use subtraction, but one thing here, I need to change, because this is a 2, this is a 5, I have to change both of them to the same number of x's. So in this case, I'm going to find the lowest common multiple, and the lowest common multiple is going to be the 10, which means I must multiply by 5 every single, let's say every single expression in the first equation, so times 5 times 5, and the second one, every single expression is going to be multiplied by 2, because I must make the x's the same number, times 2, and this one is going to be times 2. So I decided on the x's myself. If you like to change the y's, you go ahead. Right, so the first one becomes 10x plus 15y equals 150. So rewrite the new equation. And the second one becomes 10x plus 14y equals 142. So we are going to apply subtraction, draw a line, cancel them out. Now 15y, take away 14y is y, 150, take away 142, the answer is going to be 8. Here we go, we found the value of y. We need to find the value of x. And as I said previously, I'm going to choose the first one because the coefficients are smaller, less work for me, okay? So there you go, I'm going to choose 2x plus 3y equals 30. Substituting y here to be able to find the x. So 2x plus, y goes here, right? 3 times 8 equals 30. So 2x equals 3 times 8 is 24. Take away 24 on both sides. Take away 24, take away 24. So this side is going to be 6. 2x equals 6, and then divide by 2 both sides. Right? Divide by 2, divide by 2. X is going to be 3. And this is the end of solution of this simultaneous equation. So x equals 3 and y equals 8. Right. Let's have a look at another one. Now, here I have, again, I'm going to choose the positive ones for x and 2x. And by doing, again, they are both positive, but this one is not the same as the first one. So I can just multiply the second equation, every term of the second equation, or every expression of the second equation by 2, because I want to make 2x into 4x. So times 2, times 2, times 2, right? And I'm going to rewrite both of them. Now rewrite the first one as it is, plus 3y equals 27. And the second one becomes 2 times 2x, 4x. Now minus 2y, okay, equals 34. Right, so 17 times 2, 34, minus y times 2, minus 2y, 2x times 2, 4x, right? Draw the line and subtract. We're subtracting to get rid of the x's. So 3y take away 2y equals y, 27 take away 34, it is going to be minus 7, okay? Minus 7, in this case is negative. Right, let's find the value of x. I'm going to choose the second equation, less coefficients. So I'm going to rewrite and then I will substitute. I have to be careful here with the negative because I have negative, negative. Let's see how I substitute. It's minus y, so minus, open the bracket, minus 7. Because minus is part of the equation, but the y itself, it is minus 7, right? That's how we substitute the negative value. So 2x now minus 7 becomes plus 7 equals 17, right? Take away 7 on both sides. So 2x equals 10, right? And so divide by 2 both sides, divide by 2, divide by 2. X itself is going to be 10 divided by 2, 5. So we found the y here and we have the x here. This is the solution of the equation, of this pair of simultaneous equation. Again, we substituted. Now, let's have a look at this one here. Again, we can substitute because 4x and 4x, both of them are are positive. We need to get rid, to be able to get rid of them, we should substitute. How about this one here? Let's say if I have an equation like that, this one here. Again, I'm going to stick to the positive one. This is what I'm going to stick with. Or because I see the coefficients are both 3 minus 3 in this one here. Again, because I want to get rid of one of them, what I do, I'm going to multiply the bottom one by minus 1, right? Because all I need to do is just focus on the terms, the letters, or the unknown, the variable that has the same letter, but I can change to the positive one, because all I want to do is substitute both of them, okay? Right, so I'm going to multiply the second one by minus 1, times minus 1, times minus 1, times minus 1. And you see why I've done this. Let's rewrite them both. So 4x plus 3y equals 32. So this one becomes minus 5x, all right? Now minus 1 times minus 3 becomes plus 3y equals minus 13. Can you see now? Now, if I take away both of them, then I can get rid of 3y's easily because I'm subtracting. I always subtract. 4x now minus 5. Remember, minus becomes plus. So 9x equals, cancel them out, 32 minus 13 is going to be 45. And then divide by 9 both sides, divide by 9, divide by 9. Well, the answer is going to be 5. There we go, just like that. Cancel the 9's out. X equals 5. Now let's find the y. I am going to choose the second equation. You can choose the first version of the second equation. So I'm going to rewrite 5x minus 3y equals 13. I substitute the 5, so 5 times 5 minus 3y equals 13. 5 times 5 is 25, so 25 minus 3y equals 13. Okay, let's get rid of the minus 25. I like to get rid of the numbers that I call loose numbers on the side of the variables. So minus 3y equals 13. Take away 25 becomes minus 12. Divide by minus 3 both sides. Divide by minus 3. Divide by minus 3. Now, let me explain something here. Because usually I have students that say, well, we have to add minus 3. Actually, minus 3, how is it linked to y? It's by multiplication. It's minus 3 times y, right? It is not y minus 3. It is minus 3 times the y. That's why you apply the opposite operation, which is a division, to get rid of the minus 3, all right? Divide by minus 3, divide by minus 3, get rid of the minus 3. So y equals, now here be careful, we divide two negative numbers and the answer is going to be positive. So y equals 4, x equals 5, y equals 4. These two are the solution of my simultaneous equation. So can you see what I did here? I used those two that are one positive and negative, and I changed the negative one into a positive so that I can still apply the subtraction. Right. Here again, I can apply subtraction. I'm going to choose these two, for example. This is your work, it's independent work, but a little explanation. I'm going to choose these two, right? And to be able to get rid of the y's, then you should change the 2y into 4y. So you multiply the top equation by 2, every single expression of the top equation by 2, right? Okay, let's have a look at the b. Okay, I like to change this one to 2y. How do I do it? Multiply by minus each side, turn this into a positive, and then multiply by 2 each side, turn this into a positive 2. Or multiply by minus 2, so that I can apply the subtraction again. Here, which one do I look for? I've got both of them as positive, so I change both of them, 4x and 3x, into the same number of x's. So by finding out which one is the lowest common multiple, in this case it's going to be 12. So multiply each term of the top one by 3 and each term of the second one by 4. In here, both of them are positive, x's and y's are positive. Again, I'm going to change the x's, both x's, because again, I want to subtract both of them to the same number in front. 12 is the lowest common multiple, and that's what I'm going to do. So multiply by 3, the top one, multiply by 4, the bottom one. Now here, now can you see this one looks a bit different? So what you need to do, you have to rearrange. You have to put them into a form x something, x plus y equals something. So here, you need to, so the first equation becomes like that. So we have 6x plus 2y, so if you rearrange plus 2y equals 52. And the second one, 5x plus 7y. Can you see 5x plus 7y? 7y equals 70, equals 70. So the x's should be under x's, y's under y's, to be able to, 52 here, to be able to do the right operation. And you have 6 and a 5, 2 and a 7. Which one you want to change into the same number? I like to use the x's, for example, 6 and a 5. I can use, it's going to be 30, or for a 7 and a 2, I can use the 14 as the lowest common multiple. So multiply the top by 7, the bottom, every single element, every single term of the bottom by 2. Or if you want to work with the x's, multiply every single term of the top equation by 5 and every single term of the bottom equation by 6, because you want to make both of them 30, and you want to subtract. So I've chosen subtraction only, and I advise you to choose subtraction only as a way to remember, to remember that that's what you're going to be doing. So you focus on to changing the sign, multiplying by minus 1 of the equation to be able to change the sign either of x's or y's to a positive one. And also the number should be the same. And so you can subtract and get rid of one of the variables. So this is what I would do, so that you're not confused which operation to choose. Do you need to take away or do you need to subtract? Which variable? But if you know that you only want to subtract, then you work with that particular variable to change both of them to positive and to change both of them to the same number. So that is my advice. You can do whatever you want. If you choose another method, it is absolutely fine. There are other methods to choose simultaneous equation. Anyway, so thank you very much for supporting Mathssteps, and have a lovely day. Thank you. Bye-bye.